Going to go ahead and get started. I hope you guys are enjoying lunch. We've got our final session, second to final session of the day. This session is called The Now, the New, and the Future, Transformative Trends in Building Technologies. And this is the closing general session, which will focus on innovative solutions and best practices in developing walkable, livable, and vibrant communities. And I want you to just take this all in as we join these experts in their fields of choice as they share the current trends in building materials and technologies, helping to drive faster and smarter production of housing. Okay, and so we have a couple of amazing folks up on the stage, and I'll introduce from here all the way over. We have Zach Mannheimer, who is the founder and chairman at Alquist 3D and co-founder at Atlas Community Studios. We have BJ Siegel, and as I was reading his bio, I want to call him the Johnny Ive of Apple retail development. So I'm going to give him that moniker. And I also heard he's a Pittsburgh man, so that's all right. It's all about the black and gold. We have Peter MacKeith, who is the Dean and Professor of Architecture at the Fay Jones School of Architecture and Design at the University of Arkansas. And then my dear friend, Duke McLarty, who is the Executive Director of Groundwork and the sponsor for this particular luncheon. And I just want to point out, yeah, you can clap if you want. That's fine. Go ahead and clap. Duke and Isabel Gamara and the rest of his team at the council are doing some amazing work kind of putting into place what the ULI, Northwest Arkansas, is doing and what so many other organizations are doing. And I kind of think of the council as the glue that kind of brings it all together, taking that vision that Sam Walton had so many years ago, and now we see the fruits of that. And so without further ado, I want to welcome Duke McLarty. This is going to be a really interesting session. I think you guys are going to enjoy it. If you need seconds, help yourselves. And remember what I said, don't take any alcohol outside of this room. All right? Duke McLarty, it's all yours.
Thank you so much, Randy. It's great to be with you all today. We're thrilled to have each of you join us today for our fifth and final session in our year-long speaker series. For those of you who couldn't make it to our first four events, please look for those on our YouTube channel. We have covered a broad range of events, all the way from community design, community engagement, and now today with alternative building technologies. I want to thank very quickly the Walton Family Foundation for their support of today's program and the speaker series. And I also want to give a very special thank you to ULI for allowing us to partner with them here at the Place Summit, particularly Megan and Wes and the whole ULI team. Thank you so much. I'd also like to thank, and Randy mentioned them, Isabel Gamara, Groundwork's Communications Director, and Lindsay Navarrete, Groundwork's Communications, Social Media, and Event Manager. We don't have a speaker series without them, so they've just done incredible work this year pulling these together, and really want to take a second to acknowledge them. That's right. Thank you. So for the past 20 months or so, my team and I at Groundwork, we've been working with community partners to identify and implement solutions to our affordable housing conundrum. While solutions have been proposed, one issue has yet to be addressed. How do we build less expensive homes faster? By and large, today's homes are still being constructed with many of the same materials and methods that were used to construct the homes our grandparents grew up in. Of course, there have been advancements on the margins. Our building trades are safer now than they ever have been. The tools that are used are slightly more advanced, but the approach to building homes is still largely done with concrete foundations, manually built wood frames, and shingled roofs, just like they were 100 years ago. None of these advancements are bringing efficiencies to scale in a way that's going to impact the market in a meaningful way that will ultimately impact the price of the homes. Homes today have never been more expensive to build. Materials, labor, land, and time to get a project approved are all at all-time highs. And each of these make the final product much more expensive to the eventual homeowner or renter. And that's why today we're here to introduce and discuss innovative technologies that are challenging the way our built environment is designed, built, and maintained. The way the program's going to work, each panelist is going to share a few slides that takes a deeper dive into the work that they're doing, and then we'll have time for some questions, and certainly we'll encourage your participation at that time. So joining me today is Dean Peter MacKeith. As Randy mentioned, he's the Dean and Professor of Architecture at the Fay Jones School of Architecture and Design at the University of Arkansas. Dean MacKeith is currently overseeing the completion of an $80 million capital campaign for the Fay Jones School and guiding the design and construction of the Anthony Timberland Center for Design and Materials Innovation, a regional center for research and development of new wood products and new approaches in sustainable construction materials. Welcome, Dean MacKeith.
Thank you. Thank you. For those who are alumni of the school in the audience, this is not Architectural Principles 101, but perhaps something similar. Do I advance? Here we are. This is about connecting the responsibilities and obligations of a public land-grant university, and in that, a School of Architecture and Design, to the interests of the state, its citizens, its natural resources. And it's best framed by this question: what does it mean to be a public university and a School of Architecture and Design in a state that is 60% forest? We're sitting here in the middle, I would argue, of the greatest natural resource in the United States. Arkansas is 57% forests, 19 million acres. This is an agricultural state, to be sure, but the predominant, you could say, dimension of that agriculture is its trees. And yet, for all of that, we are a state that is being overgrown. We are a state that is growing 2 trees for every tree that is capable of being harvested. And this is a surplus biomass on the essence of, a number of about 15 million tons per year. Surplus is both challenge and opportunity, as economists would say, and the challenge for us is that it is at environmental challenge in terms of a density of forest will lead to greater wildfires, greater insect infestation, greater difficulties with our groundwater. And at the same time, there is surplus opportunity in this if we can in fact devise new materials or new products for new markets, or even new uses for old products, such as dimension lumber. This is a proposition which I've made across the state and across the country for the better part of the last 9 years, which is to say that Arkansas is a forest state and a sustainable state. And in that, we all have potentially an interest in each of our roles, but certainly as a university and as a school, in the bottom of this virtuous circle, the 2 towers of Old Main represent the potential for the university to be a research and development center for the wood products industry and in that way for architecture, engineering, and construction. And it's also so, yes, that our namesake Fay Jones demonstrated through multiple buildings the virtuosity of working with dimension lumber, seeing in that simple, banal material greater possibilities of elegance, of efficiency, and altogether beauty. And this then attaches to our work as a school to disrupt, I would say, for the greater futures of our students, for architecture, engineering, construction, for the citizens of the state, to disrupt community design, health and wellness design, housing design, timber and wood design, preservation design, resiliency design. We ask these questions too, which Duke is asking as well. What does it mean to be such a school in one of the nation's leading high-growth, low-density populations? What does it mean to be a school in the middle of one of our designated resiliency regions? How can we as a school, how can all of us in this room work to address these issues? We argue through this equation: by marrying or addressing forest resources to mass timber potential, building a value ecology that has educational value, environmental, technological, economic, and societal value in the greater cause of the state. And we've done this as a school in multiple ways over the last 8 years, researching with our students the character of the forests, measuring it in phenomenal terms, as well as in design build terms, as well as in structural terms, as well as in using a wood matrix composite and beginning to 3D print this at small scale in our studios. Our Community Design Center has looked at an imaginary wood city, timberizing the 19 real estate building types of an American small town to understand how they could be optimized through mass timber construction, and understanding the virtues of mass timber relative to every other form of construction, and educating our students, the future architects, engineers, and contractors, to this way of thinking. And I won't go into great depth in this, but this is, of course, what brings us together today. How can we necessarily disrupt architecture, engineering, and construction in order to provide better alternatives to disrupt the housing market to our overall advantage? We're doing this already now in Pine Bluff in central Arkansas through reconceiving even stick-framed homes and examining the ways in which a simple stick-frame home could actually be looked at through CLT construction, through 3D printed construction, through SIP panel construction, and beginning to optimize all those forms of construction, understand what is engaged in overall budget analysis as well as life cycle analysis, and beginning to provide these types of houses at scale for ultimately 600 house development in Pine Bluff. We're also looking at this at the affordable housing scale here in Fayetteville. We're beginning to work on affordable housing that is aimed at a design to income model, that is to say for people who make $16 to $18 an hour, and how they can in fact afford such a home, and we're beginning to prototype this. But moreover, the university is investing $250 million in understanding how this type of construction, mass timber construction at that, can be utilized for a variety of academic building types that are transferable out into the larger world. The Library Annex building down on Martin Luther King Boulevard. The Adohi Residence Halls of 2019, 700 beds, 200,000 square feet, for its moment the largest mass timber housing complex in the country, optimized through mass timber glulam and CLT, and providing a premium housing location for our students. There is a mass timber business case study on this for those in the development world who'd like to see how this applies to construction and development, as it does. And there is already now another building underway, a research building, the I-R building on Dixon Street, which is, again, mass timber in its construction. So at our doorstep, all of us should understand that the university is prototyping this form of construction at a variety of scales. We sit here in the middle of the country with over 23% of the US population living within 500 miles, 16 of the 50 largest cities. And we, of course, have our own housing crisis here in this region. We think we can address this. I propose we can address this. And we should be, in fact, manufacturing our own mass timber, which we now are in Conway, Arkansas, with working with Mercer, a fantastic company that has taken over the former Structurlam plant in producing. You may know that Walmart has committed a significant amount of its new headquarters construction to be achieved in mass timber. I won't go through this, but this is available also on the Walmart website, and it too is coming forward and beginning to address the needs of a state that's 60% forest. And lastly, as Duke mentioned, we have proposed now and are beginning to live the dream, I would say, of a research and development center servicing the wood products industry of the state and the housing industry, housing needs of the state through this, the Anthony Timberland Center for Design, now under construction on Martin Luther King, which will look like this on the outside, which makes use of multiple species of Arkansas timber and wood products, which will have a fabrication workshop that will allow us to begin to prototype at scale what we call the Workforce 16 housing. And if you come to campus within the next several weeks, our students will be building a mock-up of that prototype in order to allow everyone to understand how we are disrupting architecture, engineering, and contracting through the work that we're doing. This is the value ecology. This is our answer to the question, what can we do to disrupt? What can we do to address the natural resources of the state? And what can we do as a land-grant university? Thanks very much.
That's terrific. Thank you so much. Next, BJ Siegel. He has been an architect for more than 27 years, and in 2009 became the Senior Design Director for all Apple retail stores worldwide, directing the program through its flagship development and international expansion. In April of 2019, we joked before, BJ lost his mind and got into housing, but he founded Juno, a venture-backed prop tech company focusing on designing, developing, and delivering urban multifamily housing as a branded consumer product. Please welcome BJ Siegel.
Well, thank you very much for having me. I'm very excited to share with you a little bit about the way that Juno works. We really are a company that's set out to design differently and to take advantage of some of the context that the Dean's been talking about, this new industry of mass timber products and this environment where housing really is in a crisis in the United States. So what we do is we think about the building as a product. And in order to deliver housing in a totally different way, we need to think about the process of making in a new way. So we start with this idea that in order to have some semblance of repetition, in order to systemize this idea of building, we need to start with a design that warrants repetition. And so we're very proud of the design. We're very proud of this first iteration of the product, which I'll show you in a minute. But then from that, we break down the tactics of making into these four categories. We break down the design into a component-based system of design that these pieces can then be either made off-site or made on-site, but we design them as components. We then take software and tools and we automate many parts of the design and fabrication process with the use of technology. We then leverage the ability to take third-party contract manufacturing when it makes sense and create value-added pieces that come to the site and make that installation much faster. And then lastly, because it's a program of projects that repeat and repeat off of the same system, data collection and learning from what you do and applying to the next is really quite critical. So this is just a couple images of the first product, the first building that we've taken to market. This is a market rate multifamily building in Austin, Texas. We'll see a case study of that in a little bit. But really, we're focusing on things that make it a great place to live. And we really wanted to make sure that if we were going to design a system and we were going to try to proliferate this way of working across the country or even further, that we actually are doing something that we feel proud of in the way that we bring it across. So really focusing on things that make it a higher quality place to live. Lots of natural light, very efficient use of space, expression of material, and in this case, we are very focused on mass timber as a structural load-bearing system for our projects. And then also we look very closely at the carbon story of our projects. Not only are we thinking about the operational carbon, our projects are trending about 45% better than the 2015 IECC, which is the kind of average code across the country, but really in an exceptional way, in a way that people are just kind of coming to the table with this, we're really focused on the embodied carbon analysis of the projects. So instead of letting carbon and emitting it into the air as concrete and steel buildings do, we're going to compete with tall buildings, and we want to replace that emissions of carbon with a building that can hold on to that carbon with the use of mass timber, and then hold on to that for 50, 60, 75 years as long as there's an active life of the building, and then hopefully then reuse those materials in the next life once that building has come out of its life. But you can see here on the left that we're trending towards a neutral position relative to the embodied carbon on a project on a per unit basis because of the way that we're offsetting the wood footprint with the things like washing machines and ovens that are necessarily going to emit carbon into the world. So I'd like to share with you a project that we're just finishing right now in East Austin, Texas, a case study of our first project. This project is a little smaller than most of the projects we'll go forward with, but this is really a case study to get us out the gates, get us building a project very quickly, and making it real into the world. So for us, we wanted to break down the design into a series of components, small, mostly flat packed pieces that could then be reconfigured in many different combinations in order to create all the unit types that would be available or necessary for a certain market or a certain location. By keeping that number of units very small, we can then design supply chains around that. So in the design process, in the R&D that we do, we get to know those components really well, and we get to understand the design implications, the cost implications, the schedule implications of these components, so that we understand right from the get-go them as products of their own. We understand how many connectors it takes, how many people it takes to install them, what are the dimensional tolerances required to put these things together. And then we go into very, very large, very, very deep detail to understand not only the design intent that you can see here on the left, but what a fabricator that might make something offsite would do. What would they do? What was in their scope of work? And then what is the resultant scope of work on the job site? We want to be very clear that our job is to make these buildings go much faster than typical. And as a result, we have to then be very clear with the people who are working on the job site that their scopes are going to be different. There's going to be less work, and we're going to be able to do it faster in a more systematic way. Quite important and kind of fundamental to all this is actually taking constructability coordination, not design coordination, but constructability coordination into the design process and not saving it for the general contractor to do while the project's under construction. We want to make sure that these pieces, if they're coming to the job site, are not going to be changed or modified when they get to the job site. We want to make sure there aren't large RFIs or waste on the floor in the dumpsters. We want to make sure these things are pre-coordinated so they come together and they connect in a very clear way without mistakes. So we take what is the common conventional architectural design process that one would go through. Everybody, I'm sure, in the room is very familiar with this. And because of the R&D, the components, the tools and software that we go through, we actually can screen away a number of tasks that actually typically happen on a project. And as a result, the Juno design process ends up being condensed. Less phases, less intense phases. This translates into an improvement in the design efficiency, in the design process. The project in Austin I was just showing you, we actually finished the design of that project about 60% faster than a conventional project of the same scale, and actually got through the building permitting process in just one meeting because of the depth of information we knew about the pieces of the project and how they were going to go together. We also use tools to plan out how the job will come together once it gets to the job site. Here's an animation that really was more of a planning tool than a presentation tool, but it was really a way of coordinating with the erector, the person driving the crane, to understand each individual piece that was going to come together in the job site, how they're going to be sequenced, what the safety procedures were going to be, what were the temporary measures. We went through everything, and this was really to get alignment with the installer, to make sure that we understood how many people needed to be there, how long they needed to be there, what was the schedule going to be, and the durations. Because getting this critical path right, getting the critical path through the crane is the key to making the job build faster. So in the interest of time, I'm going to skip the rest of this video and just let you see that the building went together per plan. And 5 weeks, we actually had the full superstructure put up. And I'll point out, if you could look down at the bottom left-hand corner, there's a very small dumpster and it's empty. We had almost no job site waste as a result of this process because we planned it out very precisely. We got alignment with the installer, and actually it went to plan. What was amazing is that only 5 people put that building together in that amount of time, 4 men and a woman. And it was insane, the kind of efficiency of labor on the job site and the speed at which we were able to grow. In addition to that, this data collection is quite important to us. We used some technology that we were able to then track each and every piece as it was put together on the job site, and we were then able to then tie this back to the BIM model and assign those parts the crane was lifting to the BIM model to understand which piece it was, how long it took, how many people it took to do that. And we were able to then track that data and understand where we did better, where we could do better. And if you look at the right-hand side there on the slide, the installation learning curve, even in this very small test case, 24-unit building, every floor we went up, we actually increased our productivity on just 24 units. So when we go to transition to 100 or 300-unit buildings, we expect to see even better utilization of the crane, better utilization of the labor, and that translates into economics that work better for developers. So the combination of the design process being compressed and the construction process being compressed allows us to really deliver a much faster installation on the job site in a way that we hope will take a system and propel that into the future. For us, this particular set of components is really just the first the first test case of how the way of designing, the system of designing could be operating. So we can then design other products, so to speak. We can design student housing, we can design affordable housing, we can design hospitality. Any projects that have this kind of the potential to have pieces and parts that can relate and repeat can fall into this way of working and actually have these advantages. So we think there's a lot of potential to push on housing, but we think there's a lot of potential to push this way of working into other areas as well. Thank you.
That's great. Thank you for that, BJ. I'm sure there's a lot of questions have been prompted. We'll save time for that. Next, I'd like to introduce Zach Mannheimer. In 2020, Zach and his partners launched Atlas Community Studios, a creative placemaking firm. And it was through his work with Atlas that Zach realized the number one thing holding communities back from economic and cultural prosperity was the lack of quality, affordable housing. This led Zach to found Alquist 3D, where he set out printing homes in underserved American communities. The first completed home of Alquist is in Williamsburg, Virginia, and was built in partnership with the local Habitat for Humanity chapter. That home stands as the first 3D printed, owner-occupied home in the United States. With that, please welcome Zach.
Thank you. Good afternoon, everyone. I'm here to talk about how we're not going to use wood and only use concrete. So sorry, guys. I'm joking. We do use some wood. So we're going to talk about the 3D community of the future. And everything Duke was saying is what led us to start this work is we work in 27 states around the country doing placemaking and asset-based economic development. But the number one issue we found everywhere was the lack of not just affordable housing, but housing in general. Every community in the world lacks that component. And if there's a trend that we've been following ever since COVID has been happening, it's this trend of pandemic migration. And there's article after article that comes out all the time about how people are leaving mostly larger cities and going to smaller areas. You guys know this here in Northwest Arkansas. You're one of the biggest, fastest growing areas in the country. But this is not a new phenomenon. For the past 50 years, people have left the coast of the country and they've moved inward. You can see it play out here. We work primarily in more rural communities. Average size community for us is about 5,000 people. And this is, you can see the dramatic loss throughout rural America here over the last several decades. You can see it play out in our congressional map. People are leaving the Northeast, they're going south, and they're going west. And that's been playing out for a very long time. This is a map of where they went between 2000 and 2007. They largely went to what we call second cities: Minneapolis, Kansas City, Nashville, Austin, Denver, Miami, Atlanta, New Orleans, Phoenix. These are the cities that were gaining population at the beginning of the century at identical levels per capita as a place like San Francisco saw 100 years ago. And we used to say before COVID that we were in the rise of the third city. Little Rock is a third city. Des Moines, Iowa, Boise, Idaho, Albuquerque, New Mexico, Madison, Wisconsin, Raleigh, North Carolina, Birmingham, Alabama. Those are the cities that right before COVID were on the upward trend. And we would sit there and look at the data and say around about 2030 to 2035 would be the golden time for smaller communities in rural areas because those third cities would be oversaturated. But everything changed, of course, and if there's any silver lining to COVID, which is a weird thing to say, it's simply that it finally shone a light on how bad the housing problem is in areas outside of major cities. We weren't talking about that before. Remote work is one of the reasons why, but we're in this now unprecedented three-headed monster of migration. We've always had financial migration. Now we have pandemic migration, and we have climate-based migration, not wanting to live around where there's natural disasters all the time. You add all this up, and we believe there's about 15 million Americans right now on the move looking for new places to live, work, and play. So when you look at smaller communities, there's major opportunity. We're seeing that growth already happen throughout the country in these areas. And so we used to be able to predict that people would go from first city to second city to third city and so on. But because of COVID, there's no more rhyme or reason anymore. People are going from New York City to Clarksdale, Mississippi, and everywhere in between. You can't predict it. And that's largely because for the first time ever in our modern history, you don't have to live in a large urban center to experience the best arts and culture, the best business or educational opportunities. You can do it anywhere if you have two things: a strong broadband signal and an appropriate home to live in. So when we look at these pieces of the puzzle, every community that we go to, regardless of size or location, this is our community hierarchy of needs. Each piece of this puzzle is necessary for a community to thrive. But as we look at it, housing is at the base. It doesn't matter how cool your town is if you don't have anywhere to live. So that is the bottom line that we really focus on. And then this stat is what really drives us. Every time a home increases in cost by $1,000, we displace over 150,000 American families. That's the issue that we're fighting against all the time. So with that in mind, we started Alquist 3D. We were looking at ways to drop the cost of housing. We discovered 3D printing back in 2016 and worked towards that to the area that we're at today. So inventory for homes for sale are at historical lows. We know that. The prices keep going up. We just surpassed $400,000 as the median home price in America, which is impossible to afford for most people in smaller communities. And then we've got our younger generations who enjoy doing other things, like some of the data points on this slide right here that I'll just leave there for your viewing pleasure. So here's what's really interesting, is that 3D printing is not necessarily new. This is a video from 1934. This is basically how we 3D print with concrete today, except we don't stand on a scaffold and dump it directly into the hopper. We have a slightly more efficient system to do this work, but this is basically how we do it now. Now, we at Alquist know that for us to be truly successful is when we finish a home that we can nail the choreography like these three guys do right here. Unbelievable. So, our first home that we ever printed was with Habitat for Humanity, as Duke said. They're a fantastic partner of ours. We've worked with multiple chapters of Habitats around the country. Their mission is very identical to the work that we do at Alquist. This was in Williamsburg, Virginia. This became the first owner-occupied 3D home in the world. That was not the plan. We got lucky there. This is the home. It is a 1,300 square foot, 3-bed, 2-bath, single-story, slab-on-grade home. We printed the exterior walls of the home in concrete only. The rest of the home was still built out the exact same way you would build any other home. The walls on the interior are all stick-built. That was the plan. The walls that you can see here, you would not know it's 3D printed when you go in there. The homeowner chose to cover it up with drywall. You don't have to do that, of course. But this home became that first home, and here's a short video of that home being printed. What you're seeing here is the printing of the exterior wall system. We do two sides of the wall. Each side is 3 inches wide with a 6-inch gap. Inside that gap is where you run your electrical conduit. You can put your plumbing in there, but we put it on the outside. You put rebar or all thread to reinforce if you need it. And then you go all the way up however many layers you're going. And we do spray foam insulation. You can use any insulation that you like directly into that wall cavity. And then you pour a bond beam at the top and you connect your roof to that. By doing this, we're achieving R values of 25 or more with this system. We believe that housing is going to be made more affordable through 3D printing. This is April and her son Xavion. They're the homeowners of our first home that you just saw there in Williamsburg. So here's a couple of facts and figures about 3D printing. This is where, if you've seen videos of this online, you've probably saw what I saw back in 2016. You can print a house in a day and it only costs $10,000. That is not true. There's a lot of misinformation about this industry out there, and one of our missions is to help fix that. But your capital savings come in 3 places. First of all, time. Much like what you were just talking about, we can reduce the overall time by about 2 to 4 weeks versus a normal stick-built process. Labor, we need only 2 experienced humans on the job site to make this work. With an inexperienced crew, we need 5 or 6. And then your material cost typically is lower than your wood-based systems. Now today, we're not seeing massive savings just yet. We're about on par with what it would cost to build a home in any other way. But we know that in the next 24 months, those costs are going to continue to drop. And it's important to know we've only been 3D printing homes in America for about 5 years. This is still very new. It's a brand new industry. That's what's really exciting. The other pieces of the puzzle is we know that a 3D home reduces your energy cost by 50% or more. These homes can stand up to most major storms, and they don't burn. There's a lot of other attributes to this process besides just cost saving. Now, we do have to change the way that we're running the industry. You can see here in a moment, this was the printer that we used for the first couple houses, these big giant gantry-style printers. They're enormous, and they're great, but they're kind of overkill for a single-family home. So this printer requires 4 tractor trailers to move it around. It also costs over $1 million to buy, and it takes about a week to 10 days to set up and calibrate. That's not going to work. So these are the changes to the industry that have to happen. First of all, the robots themselves. They have to get smaller, more nimble, less expensive, easier to maneuver. I'll show you in a moment the robot that we're working with to do that. We need more experience. We can't go, how many of you have experienced 3D printing a house? Right, you do? Okay, you're hired. We'll talk afterwards. But we can't find people doing it because most people don't do that work just yet. And I'll tell you about how we're going to answer that in a moment. And then the material has to become localized. Our goal with our material is to get to the point, I'm a child of the 80s, so if you've seen Back to the Future, the first one, the final scene when Doc pulls up into the driveway and he's pulling stuff out of the trash can and throwing it into the flex capacitor, that's what we want to do to print the homes. Probably not out of Miller Lite cans, but maybe, but most likely out of the material that's available locally where you are. That's where we're heading. So right now, our company, we were based in Iowa. We're in the process of moving our headquarters to Greeley, Colorado. We just worked with the state and the city of Greeley on a major incentive package to put us there. And we're partnering with Ames Community College on a training program I'll talk about here in just a moment. The printers need to be new. This is our new printer in partnership with RIC Technology out of California. We are making this printer together. This printer is way more mobile. You can drive it around just like this. It can go about 20 miles an hour. It has a 9.5 foot span reach, and you can print a 1,200 square foot home without having to move the printer. If you're going to do a bigger home, which we are doing, you do different movements of that printer. We're also working on an extension to that arm. This printer costs $350,000. You can put it on a flatbed trailer and pull it with a pickup truck, and it takes about 2 hours to set up. This is the more efficient way to do this work. In terms of the looks of the homes, we're playing with different designs all the time. Those are different swaps of a nozzle head on the actual machine, so we can smooth the concrete to make it look like stucco. We can do some fun designs. We can print your name on your house if that's what you want to do. Lots of different ideas for how to do it. The material is key, though. It's much like a desktop printer. It doesn't matter if you're using an Epson printer or an HP printer. They all basically do the same thing. Those robots are going to become ubiquitous over time. The material, however, has to be localized. So right now, we have a non-cementitious material, where part of it is recycled glass, recycled plastic. We're playing with hemp. We have graphene. We have lots of coal ash that's inside this mix. We're constantly playing with it. But the mix that we're going to print with here in Arkansas is going to be different than the mix that we're printing with in Colorado or Florida or any other part of the world. It has to be localized. And we believe we can use a lot of wood in this system and combine these worlds, which is where we're headed right now. We're not just printing homes, we're printing infrastructure. We're printing curbs in Greeley, Colorado. Curbs are not the sexiest of things, but these are very sexy. They have drainage throughout the curb system so that you can eliminate the need for metal sewer grates, which eliminates where water and debris pool on your street systems, which causes damage and costs communities millions of dollars. We can change all that by printing curbs. We're printing retaining walls, underground culvert systems, elevator shafts. My wife gets tired of us driving around and me pointing out the window. We can print that, we can print that, we can print that, because we can. That's where we're headed. So I want to take a moment and explain why we're called Alquist. My background is in theater, so of course it makes total sense that I now run a construction company. But Alquist is the name of a character from a 1920 Czechoslovakian play that no one's ever heard of called RUR. This is the piece of literature that coined the term robot. The plot of the show is man invents robots to speed up his manufacturing facility. The robots don't like how they're being treated. They rise up and they kill all the humans. Spoiler alert. But there's one human, Alquist, who's the main engineer, who believes that robots and humans can coexist together peacefully. He's spared by the robots and charged with rebooting the human race. I bring this up because it is a reminder that we are using automation to replace human jobs. We can't get around that. We have to own that, which is why we believe heavily in a workforce development program. We believe we can create far more jobs than might be taken away by using this technology. This, to me, is the most exciting part of this work. Printing is fun, giant robots are fun, etc. But the amount of new jobs that we can create through this process is huge. We're working with Ames Community College in Greeley, Colorado. We're starting a training program in January. In 8 weeks, you can take a certificate course and be certified to be a 3D printer, and we and other companies will hire you. This is the future. This is where we're headed, and we want to start kids when they're really young, getting on the job. I'm kidding. These are my kids. So we also, every Alquist home comes with a 3D printer, a personal desktop printer built into your kitchen, just like a microwave. We're doing this to help stand up the industry. In the near future, if something breaks in your home or you want to change the look or design of something, you're not going to go to the hardware store anymore. You're going to go online, you're going to download a file, and you're going to print it out yourself. Right now, we're printing doorknobs, drawer pulls, sink faucets, electrical covers, little things. We give every homeowner a jump drive with a dozen different designs that they can do, and then they can create their own. This is where we're heading. We're not just printing in concrete. We're printing with wood. We're printing with glass. We're printing with plastic. We're printing with chocolate. And yes, it is delicious. This is some footage of our current prints right now in Muscatine, Iowa. This is using that RIC printer, our new printer that I just showed you. This is the work that we're doing today, and it's going to continue to evolve. We need to be moving faster. We need to have a little bit less labor on the site. We need to have the materials drop in cost when we can actually localize the material. All those pieces of the puzzle. We need to be working with brilliant guys like this to help figure out how we put all this together. And the only way to do that is through partnerships, which is why we're really excited that we're going to be here in Rogers next year printing one of the first homes that I'm going to show you here in a moment. So there's 15 million Americans on the move. They need to find new places to live, work, and play. That means they need new homes. This is just a short list of rural communities that I've been to in the last year. Whether we're in rural New Hampshire or rural North Dakota or rural Arkansas, everybody has the same problem. This is the great equalizer. Housing is the problem everywhere we go. And I want to close with a quote from my mentor, Richard Florida, and he says, "The remote work revolution promises to change the way that Americans work and live. It will allow smaller cities, suburbs, and rural areas to compete with the superstar cities on the basis of price and amenities. It will shift the main thrust of economic development from paying incentives to big employers to investing in building up a community's quality of life. As communities attract more remote workers, their tax bases will grow, allowing them to improve schools and public services, benefiting everyone. Eventually, companies will come too. That holds out the possibility of a better, virtuous circle of economic development. I could not agree more. This is what drives us every day. And thank you so much for your time this afternoon."
Thank you so much. I think one common thread that I picked up on, but I'd like each of you to tease out a little more, is the affordability piece. How do each of these approaches ultimately bring a more affordable end product to market? And I'll start with you, Dean MacKeith.
Well, the one thing I do want to say is that you will be working with wood. I sound like Yoda in Empire Strikes Back, but you will be. And we look forward to it. And I want to say, as much as the work you're going to be doing in Rogers, we're also going to start a collaboration in the spring, working with Weyerhaeuser Funds to work with you in a wood matrix composite through your 3D printer. So
You're all witnesses.
Right? So it's on its way. And I'm reminded of the retired state forester of Arkansas, Joe Fox, who said, "You can ask me any question you want, and I will tell you the answer is wood." But to your question in particular, the affordability question is complex. I think we could all agree. And it's really, you could examine the almost typical pro forma that any developer, profit or nonprofit, needs to examine in terms of land cost, construction cost, material cost, labor cost, the financing formulas, obviously the square footage and so forth. So it's much more than simply the materials or the construction methods, although those are major components of it. And it is so, of course, right now in the housing market for a very long time. Stick-built construction has ruled the day. It remains, in many ways, the behemoth of American housing. It is less so elsewhere in the world. That is, in a way, the the number to beat, so to speak. And the challenges that stick building construction is facing now has to do with a shrinking pool of labor, of skilled labor, carpentry labor for that matter, to work on those sites, as well as at this point now in the market, the affordability is not necessarily aimed at the people demographically who need to be aimed at. There's assumptions being made about the standard buyer of a home that are very often misaligned, and certainly are misaligned in many ways with people here in Northwest Arkansas, for instance. I know very well that we have members of our staff and even members of the university faculty for whom an affordable house at $30,000, $35,000, $40,000 a year is actually an illusion. And how do we get to that? This is where such things as land values and the availability of land through land trusts, potentially, are important to think about. What we can do, I think, is really to address labor, to address materials, and to address methods of construction. We're doing this in our school this way, and by and large because of an even larger commitment to low carbon futures that we want our students to really be possessed by the time they graduate. We think we're centering our efforts within the timber and wood market. The question is going to be scale. At this point, and I think Zach would agree, and you would agree too, that to think of whether it's a 3D printed concrete or mass timber panels as the immediate future for affordable housing, we're not yet there. And to some extent it's because in the mass timber market of the relative unavailability of those manufactured panels, whether it's CLT or mass plywood or so forth. This is why it's so important for us in Arkansas to now have the Conway plant. There's one in Dothan, Alabama. There are others coming up on the Atlantic seacoast. That's going to start to change the economics of certainly a mass timber-based approach to housing. And I'd like to think, given the wood byproduct available in Arkansas as a local resource, that it could very well alter some of the economics of what Zach and his colleagues are working on so well. So again, I'll just start the conversation there.
No, that's extremely helpful, and I find great relief in the idea that you're looking at ways to impact the material cost, the labor cost, and this goes for all three of you. When I took on this work, I kind of divided the items that are leading to expensive housing across the board. And material and labor were areas that I didn't feel like, coming into this role, I could have significant impact on. But it certainly, it sounds like there's some hope on the horizon. I really, really appreciate y'all's focus on that. BJ, affordability.
I think I'm going to take a slightly different approach, but for me, it comes down to programmatic scale. And I think, one of the things that we're really driving the way that we're thinking about design is that there are many parts of the buildings that actually can be common and be repeated from project to project. It doesn't mean every residential unit needs to be the same or every building needs to be the same. These things can be varied quite a bit as the buildings then find their site and find what's locally relevant about them. But there are ways that you can then create a series of repetitions in effort so that you don't need to rethink the way a column is designed or the way a column is connected to a beam or a floor slab. And you can then take the very inefficient process that we all go through every day when we make bespoke buildings and create a system where we take advantage of that. It saves time, it saves energy, and you can then actually create a building of building really high quality, very low carbon buildings that then can proliferate across the country. And I think in this idea of scale, we've been very focused on more urban applications where you can actually take advantage of the land and actually have more people take advantage of a smaller piece of land and actually create a density that exists in cities, whether they're small cities, large cities. You could then actually create a much larger impact by creating high quality, sustainable buildings and systematizing the way that does and have programmatic rollouts. And these programmatic rollouts can be government sponsored, they can be community sponsored, they can be developer sponsored. No developer wants to reinvent the wheel every time they come to a new site, but they do.
Yep.
And it means that you can get to market much faster, you can take advantage of the capital that you're raising, and you can build much higher quality buildings as a result.
That's great. Zach, affordability.
I'll be brief because I agree with everything both of you said. And the one thing that both of you said that kept coming back is scale. This is a scale game. The more that we can print or build at the same time, the lower the cost is going to be. And it's as simple as that. But it's also new technology moving faster, et cetera. But in our country, the way to generate wealth is based upon home ownership. That's how we do it. That's how the system is created, which means that the way that we build homes is completely out of whack today and has been for decades. But we've answered this problem before. We did it after World War II. And that's, I think, some of the things you were alluding to is a public-private partnership where we have public universities and academic institutions, we have granting organizations and foundations, we have private general contractors that all work together to solve this, what I believe is the biggest issue facing every single community in our country. So it's going to get there, and I'm predicting in 24 months we're going to have a very specific answer.
24 months, you heard it.
And to this question of scale, one of the images I showed was how in most neighborhoods, most cities, most communities, most developers approach the issue of scale is by repetition of the same floor plan, the same volumetric construction, and to some extent the same stylistic appliques over and over and over again. And this homogeneity works, and this repetitiveness works to the advantage of the developer. It's arguable, and has been arguable sometime, whether that works to an overall quality of life or an overall understanding that this is my home that is individual to me, another part of the great American dream. So the challenge is, within that question of scale, is also, can we achieve what has sometimes been called variability within standardization? Right, which is also, I think, where the design element of this is actually crucial. Whether it's working with standardized panels, but in a way that allows for elasticity, or within a floor plan which potentially could be elastic altogether.
Right. It's with 3D especially, it's a change of the code. So we already know we can print two houses next to each other that look very different without increasing cost. It's just a different code, and we input it into the robot, and it moves over onto the second site without us having to change anything. But design is going to be crucial because we don't want cookie-cutter neighborhoods. These have to be unique, otherwise economic development goes out the window.
This is one component that we're working on as well in terms of the true affordability, which is somebody making $16 to $18 an hour. There are a lot of people in Northwest Arkansas who make $16 to $18 an hour. We know some, I know. And the question is, how can they be provided the opportunity for home ownership that is individual to them? As part of this, again, coming back to the pro forma, is can we reduce the design fee or the design cost on a pro forma? We think we can, still achieving this variable standardization, but essentially making that design available as a licensing fee more so than as a specific architectural cost, right? That would vary from project to project. There are different ways of getting at this too. You surely have thought this through in your business models.
Yes.
One of the areas where I have spent a fair amount of time is the regulatory environment. Particularly BJ with your first development in Austin, and Zach, your first work. What are some of the regulatory challenges or barriers in developing with this approach?
Well, I'll say that right out the gate, we were a startup, so we had to move quickly. And so differently than I think what Zach's doing, we said we were not going to invent anything. We're not going to run up against anything that wasn't by right. And around the time that we were developing this system for making, there was a major change to the International Building Code that allowed mass timber, which had been being tested and being adopted over time, to become part of the mainstream. And the International Building Code that allows this new Type 4 mass timber is not by right in every state. It's being rolled out across the country. States are allowed to adopt that code whenever their 3-year cycle comes around, and so it will eventually make its way across. But there is a groundswell. More than 50% of the states have either pending or adopted this new mass timber code. And as a result, you can move very, very quickly into tall mass timber buildings in a large percentage of the country without asking for any code exceptions. And for us, that was really critical because we were thinking of a new way of designing, but we didn't have the time to test everything and create new material research like Zach's doing. We had a different mandate. And so for us, we were trying to get out there as quickly as possible and find a way of really taking it and being an example of how you can take this new code and really make it happen. And so the experience that we found is that building officials and local jurisdictions are enthusiastic and really excited to actually have this new way of working show up in their communities because of the economic benefits, because of the environmental benefits. And even in places, for example, Austin, we started this project. It was a smaller building as a result. It didn't need to actually be a type 4 building, but it was using the materials and methods of these taller buildings. The building department was so excited to have a dry run and kind of know what was coming. And they, all of the inspectors came out and took a field trip, so to speak, to see it. Yeah. And that just helps. And so it depends what you're pushing on. If you're pushing on new technologies and you have to test and prove it, then I think there are some hurdles that you have to go through, and there's a process to do that. But you can be innovative without doing that. I think that's an interesting lesson that we always joke that we're kind of revolutionary incrementalists. We're actually, coming to the market where it is and trying to really push on the way of adopting things within that market.
That's great.
Top two questions we get. Number one, how do you hang a picture on the wall? That's easy, concrete anchor. Number two is, can you get past code? Everywhere we get. And we thought it was going to be a big problem getting past code, and it's not. The good news is that almost every community has codes on their books that allow for concrete buildings, concrete structures. And that's really there's not much of a difference here. It's a concrete building. We're not pouring it in a form, we're extruding it with a giant robot, which is weird. But otherwise, this is an educational issue. We haven't had, and the best part is in the 4 states where we've passed code, we haven't had to change the code. We thought we would. We haven't had to change the code at all. They allow for this. Now, there needs to be more advances. We work with ASTM all the time. We were at their conference last week. There will be codes for this which allow for bigger structures, going up multiple stories and going vertical, which is really where we're going to see the cost efficiencies come in. That's the stuff that has to change, but code's not the problem.
That's great. If there are any questions, please prepare those. Isabel has a microphone. Just raise your hand. There's one over here. Maybe, Isabel, while you make your way there, I'll make reference to the slide that you're all looking at. This is, and Zach made reference to this in his remarks, this is a demonstration project that Groundwork has partnered with Alquist. Marlon Blackwell and his team have taken design responsibility for this, and this is conceptual. It has not been to the city or through the city yet, but just thought we would give you all a preview of this. It was announced several months ago that we were working on this. Zach, there's a few more. And as you see, I think these can fit into the fabric of the community quite nicely. These will be 2-story side-by-side duplexes. And Zach, correct me if I'm wrong, but the 2-story piece of that, this will be one of the first 2-story printed.
It'll be the second one in America. The first one's in Houston. There's only 5 of these in the world that have gone up above 1 story. This will be the first duplex that's ever created. But this concept came out of an idea that my colleague who's sitting back there, Joe Crimmings, had this idea for a Usonian home, taking Frank Lloyd Wright's concept where he got a letter 100 years ago from somebody saying, hey, I want an affordable home, but I also want it to be beautiful and high quality. Can you build that? And can you design that? And that's what he did. And the material he chose was concrete. And so that idea of a Usonian home, of a workforce housing, just because it's quote unquote affordable, doesn't mean it can't be beautiful. and high quality. And that's the exercise that we're trying to do. And with Marlon's team and going through the design, we've come up with some pretty amazing ideas. Oop, I went too far.
No, that's perfect. No, feel free to scan our QR codes, join our
That's it,
social. Isabel?
Yep, so question here in the middle. Zach, if you could talk about utilization of the local materials when we were watching the robot form the walls, or pour the walls, I should say. Are you mixing that on site with a central batch plant, or using local ready mix companies, or can you kind of expand on that a little bit?
It's a great question. We'd love to use local ready mix. We'd love to back a truck up and pour directly in, but we don't use enough material to allow for that yet. So a 1,200 square foot home uses roughly 25 yards of concrete. So we're not at that level yet, but to answer your question, yes, we are mixing on site. So what you didn't see on camera is to the right is the messy part of this, which is you have a concrete silo. So we take super sack 3,000 pound bags of material, dry material, dump it into the silo, goes into the pumper and mixer where it gets hit with water, and that's the delicate ratio. The biggest issue we have is weather. And we're constantly changing that ratio as the day goes on based on the humidity in the air, and we have to look ahead of time. There's a lot of factors that go into it. That's the science part of this. That's the hardest part. Then it's pumped through the hose directly into the nozzle head and lays it out layer by layer.
Back there.
Check. Okay, cool. I'm Isaac Stevens. I wrote this down before you showed the duplexes. All the 3D printed homes that I've seen are single-family developments. Is there plans in the works to make 3D printing capable of producing more missing middle style housing?
Yes, apparently we're going to do that also with wood here in Arkansas. So we're planning that right now. But and that may be. But yes, the ultimate goal of this is to go vertical. And shared wall systems is how we can create the most efficiencies using this technology. Really, it's so early. You know, globally, there's about 50 companies doing this work. To me, this is like Silicon Valley in 1972, but spread out around the planet. We all know each other, all 50 groups, and for the most part, we play nicely in the sandbox. But there are no best practices. We're creating this as we go. That's really our biggest challenge. We can't turn to a group and say, you know, how did you do that 10 years ago? Because it didn't exist. So we instead share our challenges with each other, and we're building this as we go. But so the 2-story will be done here next year. Going up 3-4 stories, I'm hoping that by 2025, 2026, that's what's going to happen. And where we want to get to is by, I'd say 2030, but way before that, you're going to see these robots on every job site in America complementing the work that's already going on, using other materials like wood, having this mix of materials go on. You're going to be able to rent one of these printers and do a project yourself. That's where we're headed.
Just to add a commentary to that, we've talked about scale in terms of repetition. We could also talk about scale in terms of height, yes, or in multi-level, multi-story, and achieving density relative to our town centers, which are highly desirable as neighborhoods to live in. That walkable neighborhood is, I know, of another focus here. And so there are code issues relative to the construction with these materials, but there are other code issues, zoning code issues, that have to do with achieving greater density, especially in and around our town centers. And that's another level of political discussion, societal discussion, economic discussion. Everyone wants to live close to those amenities. Nobody in particular these days wants to drive 40 minutes to get there. So we can achieve scale in a number of ways. And frankly, I have to say, I am so little interested in the tall building, timber building in the world. I am much more interested in affordable housing achieved at scale for the greatest possible number.
It's like the dean took my talking points and just incorporated them into his remarks. Maybe time for one more question right there.
Hi, I heard the first presenter make a claim that these forests have a negative impact on stormwater. Considering one tree can soak up 11,000 gallons of water per year and recharge groundwater, can you tell me what the basis of that claim is?
The claim that it affects groundwater?
That it has a negative impact on stormwater, that forests do.
That was not really my claim that it has that. It's that when those trees either stand dead in the forest or fall dead in the forest, that they then, and rainwater passes through them, they can have an effect upon water quality, not so much about stormwater management.
All right, maybe one more.
You talked a little bit about some of these creative ideas meeting code regulations and building construction regulations. What I've found personally is that getting past city planning and some of those are the biggest obstacles that you face. I think that the marketplace and entrepreneurs like yourself and others have great ideas, fantastic ideas to address affordable housing through materials and density and concepts, but getting planning at municipalities to approve those seems to be the biggest obstacle.
I'll actually reference, I think as the dean said, it comes down to not just having a system or a technique of changing the efficiency of construction, but you need to pair that with good quality design. Good quality design will get you through those planning departments, those neighborhood review committees, et cetera. If you have good quality design paired with these technologies and techniques, then you will succeed. And I think that's, we actually had a project on the boards in Seattle, and our project was actually held up as an example, even though it had all these techniques and efficiencies built into the way that we were designing things, repetition, for example. The neighborhood review board said, this is actually what we should have as housing in Seattle. Because of the textured and depth of the facade, because of the activated street, because of the local, the way it tied into the topography. And so I think it's really important to always understand which parts of the project need to be locally relevant and respond to the kind of environmental conditions of the place, the cultural conditions of the place. And we have to make sure that we don't blind ourselves that technology is going to solve the problem. We actually have to have good design that is partnering with technology and new material innovation in order to actually achieve the outcome as a holistic vision for the site.
I agree entirely, and it's not just good design, it's practical design.
Absolutely.
And that, with 3D printing, if you go online and you look at videos or images of these homes, you can see some crazy futuristic designs out there, of which we have some of those designs. You saw our homes, they are not crazy futuristic. This is not the Jetsons. We don't work for Spacely Sprockets. But can we do those designs? Yes. Would they pass a review board? I don't know. Probably not today, which is why it was a conscious decision to play with this design now. It was also important to do a design that fit into the neighborhood where we are. We don't want to create a home like Gru's home in Despicable Me that obviously sticks out from everywhere that you see. It has to be something that blends into the neighborhood and creates that fabric. We will be doing some crazy fun designs down the line, but that's not where we start.
Here,
Last point.
some years ago, pre-pandemic, if we can remember that era, we undertook together with a number of partners in Northwest Arkansas a symposium and a competition and a studio all focused on issues of housing in Northwest Arkansas and brought together, I think, a pretty good group of people to talk about it. It was agreed at the end that there is a crisis in this region that needs to be acknowledged openly without panic, but nonetheless needs to be understood and labeled as a form of therapy first, but now to start to work on it. I think the other thing that was agreed upon is that whether it's what's called missing middle or workforce housing or attainable housing or affordable housing or workforce housing for people who make 16, it's the entire income spectrum at this point that is caught up in this potential crisis, wherever you find yourself in life on that spectrum. And I think to admit that, first and foremost, is maybe what has brought us all together. But it is a question of planning. And increasingly, I have understood that this is an issue that's as important to the mayor of Bentonville as it is to the mayor here in Fayetteville. And I know more directly about this in Fayetteville, that this is front and center. And it is being addressed in the city council on a regular basis, aggressively, with deep concern. And if we can contribute to that conversation productively and contribute ideas, and I think we are, we have to come at this from every single vector at this point. There's no, as yet, there is no bad idea other than to not do anything.
That's great. With that, Zach, BJ, Dean MacKeith, thank you so much.
It's like,
wow, what a way to end this program. And honestly, if you had your bingo card and you had Spacely Sprockets in the middle, you won. So
I got prizes later.
Yeah, I like that mention. So thank you guys so much for a wonderful and enlightening conversation. We are about to wrap this up. Can you believe it? Give yourselves a round of applause for making it to the second day. That's huge. That's huge. A lot of great information has been shared. I know all of you have your notebooks filled up. I will be checking them at the door before you leave, so be sure to see me at the end. But we have one more event that's going to happen, so we're going to take a few minutes of break, and then we're going to have our summit roundtables. We had them yesterday. There were some really illuminating conversations that were happening yesterday. I really want to encourage you to avail yourselves of those this afternoon. So this is an opportunity for you to delve deeper into the conversation and insights from the sessions that took place earlier today. This is your opportunity to share your thoughts, ask questions, and collaborate with fellow summit participants to explore the nuances of each session topic. So we're going to have multiple discussions happening concurrently, so you can just come in and you can sit at one table for a minute and then go to another table and sit there and share your thoughts. But it's just important that you do that, because this is where when this discourse happens, that's where you start to see the change take place. So, of course, these thought leaders, they're all making change happen, but it's incumbent upon each and every one of you at these tables to be a part of that change that we so desperately seek here in Northwest Arkansas. Does that sound fair? Yeah. Come on, you guys, does it sound fair? Okay, come on, let's do that. All right, so we're going to go ahead and do that. We're going to take a quick break. I lastly want to mention those of you that are on the afternoon tours, we have had to grab some umbrellas because we got a little liquid sunshine out there. So I want to make sure that we will have umbrellas for you for the tour. If you haven't signed up, I think there may be some spots left for that. I believe the Insight dinner tonight is full, but we still have space for the tours, and we do have umbrellas for you, so never fear, we've got you covered. The Summit Roundtables will take place in here in exactly 10 minutes. So at 2:10, we'll get started with the Summit Roundtables. Thank you.
That'd be great.
Thanks so much. Appreciate that.
Thank you.
Thank you so much.
Thank you.
Appreciate that.
Yeah.